The image of a dog was touched by the user and the toast appeared saying dog. So now let's look in a little more detail at the steps that are used to do the inference on the image and get the results back. Typically, you'll follow a process like this. Begin by initializing the interpreter with the model that you want to use. Then you prepare the input that the model will take. For example, in the case of the image, you'll need to resize it to the size that the model was trained for. Then you'll perform the inference using the interpreter before finally getting the results and using them. Let's look at the first step now, and that's initializing the interpreter. Setting the interpreter's options is one of the preliminary steps to get started with using it. This is entirely optional, as a TF-Lite model can be loaded without setting these options, and the interpreter will just use the defaults, but I think it's good to know what the options are. These various options allow you to change the number of threads that the interpreter will use for inference with the setNumThreads call. You can then leverage the neural network API to enable hardware acceleration on your device where it's available. One cool feature is that you can use mixed precision calculation in your models when possible by calling setAllow FP16 precision for FP32 and setting its parameter to true. And of course, you could instruct the interpreter to add a delegate to utilize the GPU if it's available. Here's an example of using the options. I create an interpreter.options object and set its properties. So for example, if I want to use 5 threads and turn on the neural networks API, I would do it like this. When it comes to loading the model and the labels, there's a few steps that you need to go through. Let's go through this piece by piece. First of all is loading the model. The TF-Lite file that you created when used in Android should be placed in the Assets folder. You can load resources from here using the Asset Manager as shown to get a file descriptor. The file descriptor is then passed to a file input stream object in order to set up an input stream. The file will be loaded into a file channel, which needs the input stream as well as the start offset and declared length of the file. And to get the model representation, we then map that file channel to read in the raw bytes of the model. Once we have the model, it's then simple to instantiate the interpreter by passing it the model and the options like this.